What's happening, everybody? Pastic here again. We got one more calculus video here on the intermediate value theorem. And in this example, well, the reason I'm showing you this example is because when you're working through it, it tends to get a little tricky. You got to recall some knowledge about logarithms. So, intermediate value theorem, as usual, per step one. We got to talk about continuity on the interval 3 to 5. So step one, f of x is exponential. I'm just going to be very formal again with all of this. And therefore, continuous everywhere. Cool, so that's step one. So far the intermediate value theorem does apply and we're in good shape. Step two, let's check out the endpoints. So f of 3 is going to equal negative 1/2, negative 3 plus 3. So negative 3 plus 3 is 0, anything to the 0 is 1, so we've got negative 1. F of 5, whoa. F of 5, let's see, we have negative, whoopsie daisy. Hold on a second, y'all. Sorry about that, y'all. I tried to use my brand new stylus to write on my board, but apparently it screws it up. So F of 5, for the third time, negative 1/2. Negative 5 plus 3 minus 2. And I'm now realizing that I screwed up top, so I'm going back to that. It does not equal negative 1. I forgot the minus 2. So 1/2 to the 0 is 1. Negative 1 minus 2 is negative 3. Whoa. Having some difficulties here. I might be getting a little hungry. And it's screwing up with my brain cells. So, I think that's cool. Now we go down here, we got negative 5 plus 3 is negative 2. 1/2 to the negative 2 power makes it flip over. It takes the reciprocal of the base, so it's actually 2 to the second power, which is 4. So this is actually negative 4 minus 2, which is negative 6. Isn't that special? So now the question is the y value that we're looking at in between those two? And it is. So that's good. So now we got to say that. So we got to say, since f of x is continuous on 3 to 5, and f of 3 is greater than negative 4, which is greater than f of 5, VIVT applies. Not only does it apply, but it guarantees that we can find an answer to this. We can find our value of C. So let's have at it. Let's find C. So what are we going to write? We're going to write negative 1/2 to the negative C plus 3. I'm just going to use C instead of X here. Minus 2. We want to know where does that equal negative 4. So we're going to start working backwards. So we're going to go ahead and we're going to go ahead and add 2 here and here. So I got negative 1/2 negative C plus 3 equals negative 2. I want to get rid of the negative over on the left, so I'm going to multiply by negative 1 everywhere. So now I've got 1/2 to the negative C plus 3 equals positive 2. And now we've come to the point where this is the reason why I wanted to show you this one. So this is an exponential function that we don't typically know how to solve unless we have a good knowledge of logarithms. And there's a bunch of ways I can do this. Probably my best bet is to go the more procedural way. There's two different ways I can show you. So I'll show you the slightly longer but more algorithmic way. Let's call it that. So the first thing I'm going to do is take the logarithm of both sides. So this is now going to become, I'm taking a common logarithm of both sides. So log of 1/2 to the negative c plus 3 equals log of 2, common logarithm of 2. And we know that the power rule of logarithms allows us to bring this guy as a coefficient. So now I've got negative c plus 3 times the logarithm of 1/2 equals still the log of 2. And I should probably put this in parentheses. And I'm trying to now isolate c, so I need to divide it by the log of 1/2. So now I've got division here by the log of 1/2. Division here by the log of 1/2. So what have I got now? I've got negative c plus 3 equals log of 2. And there's all kinds of things I could do. I could be using the change of base theorem to rewrite this. But I'm trying to be sort of as procedural as possible without going too much into all that, just in case you don't know how to do that. And the last step would be to subtract 3. Well, actually not the last step, second to last step. So now I've got all that minus 3. So I got negative c equals log of 2 over the log of 1/2 minus 3. And if I were to get rid of that negative, my final sort of thing that I would want to plug into my calculator would be negative log of 2, or my final expression I should say, over the log of 1/2 plus 3. And that's essentially by multiplying all this by negative 1. So I'm going to type that into my calculator exactly as I see it. So handy dandy calculator, get out of here. It's from the last video. What am I typing in? No idea. Negative log of 2 divided by the log of 1/2 plus 3. So negative log of 2 divided by the log of 1/2 plus 3. Let's make sure that's what I wanted to write. It is. Enter. And that is our value. 4. Freaking all that for 4. So there's definitely an easier way to do it, but it takes a lot of background knowledge. So real quick, let me just show you one other way and see if you like it. Although you're not going to be able to tell me if you like it, unless you comment, of course. Going back to right here, no, not right there. Going back to right here, which is our exponential function that we wanted to solve. Let's see if we can do that in a more efficient way. So let's take that, let's go over here, and let's rewrite it. So what I'm going to do here is I'm going to use my knowledge of logarithms. So I know that this is the base, 1/2, and this is the solution of the exponential function. So I can rewrite that as a logarithm right away. I can write log with a base of 1/2 of 2, and remember the solution to a logarithmic expression or equation is always the exponent, equals negative c plus 3. So I can already rewrite that in a totally different format. Now, I mean, you got to know logs in order to do this. So what is this asking right here, this rectangular box that I just put here, the log base 1/2 of 2, it's asking what power of 1/2 gives you 2. Well, I know 1/2 to a negative exponent, the negative 1 gives me 2. So this is actually equal to negative 1. And now we'll look at the simple equation we can just solve. We can go minus 3, negative 4 equals negative c. C equals 4. So that's way more efficient, but it requires that background knowledge of logarithms. That's it for this time. I hope this helped. Catch you all later.